Here the topic is ether formation and ether cleavage. Ether formation and ether cleavage. What is ether? ROR dash. Yes. So here R dash is equal to R और R dash is not equal to R. दोनों में कोई भी हो सकता है. Yes. If R dash equal to R, that is symmetrical ether. Both sides same. If R is not equal to R dash, that is unsymmetrical ether. Right. Our topic is formation of ether and cleavage of ether. First, formation of means the preparation of ether, the named reaction, that is Williamson synthesis. Williamson synthesis. Williamson synthesis. Right? What is this Williamson synthesis? We are taking alkyl halide plus sodium alkoxide. Then we will get ROR. Just what is your work? Just you have to remove this NaCl. Okay, just NaCl. Then you are getting ether. Very simple mechanism. Okay, Williamson synthesis. Suppose if I take ethyl chloride plus sodium ethoxide C2H5ONA. Okay, I am taking here Williamson synthesis. This chlorine and Na is leaving. Here we will get C2H5O C2H5 diethyl ether, symmetrical ether. It is a diethyl ether. IUPAC name is IUPAC is ethoxyethane. Right? Like this, ethers are forming. Now, cleavage of ether. So, how this cleavage? For cleavage of ether, the reagent is HI. Right? Now, suppose methyl oxygen ethyl is there. So, now where the bond will break up? Yes, either A position or B position. If A position is there, it will give here HI may H plus I minus. So if A position is there means obviously this is the negative particle, alkyl is the positive. So CH3I and C2H5OH. This is one option. Then option 2 is CH3 means B breakage is there. It is breaking at A, breaking at B. If CH3OH plus C2H5I. Okay, these two products are possible. In this, the major product is the first one. Why? The reason is here this reaction is following SN2 mechanism. This reaction is following SN2 mechanism. In the SN2 mechanism, no intermediate. First point, right? Then the second point is nucleophile attacks at sterically free side, right? So here ethyl and methyl is there. Here nucleophile is I, so the I will attack sterically free, right? So methyl iodide. But here few questions are there. You had to practice those questions. Suppose CH3, now HI. What are the products where the bond will break up? Here also option A and option B is there. So obviously option B is correct. Why option A? Why not option A? Here due to the resonance, here double bond nature is there in between benzene and oxygen. So see, I will write one mechanism here. OCH3, here oxygen has the lone pair, two lone pairs. So one of the lone pair is giving here, then immediately this benzene pi bond is shifting. So oxygen getting positive charge. So benzene ring is getting negative charge at ortho and para positions, right? So here in between oxygen and benzene ring, here double bond is there, right? This is a double bond. So due to this double bond breakage is very difficult. That's why here at B position bond cleavage takes place. So the product is phenol plus methyl iodide, right? Next, one more important point here. Suppose like this is there, methyl, right? So in this case, which mechanism it will follow? Here SN1 mechanism it is following, SN1 mechanism. So you note down here, note point is if ether has tertiary carbon, it follow SN1 mechanism. What is SN1 and SN2? In the next video you can see. It follow SN1 mechanism, right? So in case only primary or secondary carbons are there, secondary primary carbons are there, it will follow SN1 mechanism. It will be undergoing SN1, sorry, it will undergo SN2 mechanism. SN2 mechanism, right? Now, so what is the product now? So here SN1 mechanism. In SN1 mechanism, intermediate is forming. In SN1 mechanism, intermediate is forming. This is the your reactant. So here following it is SN1 mechanism. So intermediate is forming. Intermediate forming means obviously tertiary is the more stable. So it is forming like this intermediate, then CH3O Na. Okay, why we are taking this HI here, right? HI means I will attack there. So first of all here protonation takes place. Right? OH. So this all carbocation react with I minus and forming 1, 2, 3, 4 tertiary butyl iodide. Okay, SN1, SN2 mechanism you understood now. If primary and secondary are there, SN2 mechanism. If tertiary carbon is there, then SN1 mechanism. Reason is more stable carbocation is forming. Here you can see here, this is the CH3. Here also CH3. Here also CH3. Three donating groups are there for this middle carbon. Middle carbon has electron deficient, but 3 donors are there, so more stable, right? Ether formation and ether cleavage, it's over.